Hi guys, and welcome to another video. Today we're going to be looking at calculus, and this particular question appeared in the November 2017 video. And as you can see in this particular question, it says find the derivative from first principles. So when you find the derivative from first principles, you have to use the formula, which is f primed x equals to the limit as h approaches 0 of f of x plus h minus f of x all over h. So in this particular video, we're going to be looking at the steps to find the derivative from first principles. So let's get started. So 7.1. So here we're going to be looking at in f of x. So the first step is going to be to, let's write down our function. F of x equals to 2x squared minus x, step 1. Now let's substitute f of x plus h wherever we got x. So where you're going to put x plus h there, all right? So 2 into x plus h, don't forget all squared, minus x plus h. So what have I done? Wherever I got x, I put in x plus h. So all I'm going to do now is simplify. 2 into, so let's open up these brackets. X squared plus 2x h plus h squared. So I'm squaring this binomial. You see that binomial, you can work it like this. X plus h times x plus h is equal to x times x is x squared plus x times h is x, h plus x, h plus h squared, which is going to equal to x squared plus 2 xh plus h squared. Or you can use the rule, square the first term, double the product of the two terms, and square the last term. Okay, and you'll end up with this. Alternatively, you're going to be working with this so often, you'll probably memorize it. Minus x minus h. So now that we've got this, we're going to simplify further. 2x squared plus 4x h plus 2h squared minus x minus h. So we've got f of x plus h, which will actually fit nicely into your formula. The formula now has f of x plus h and f of x. So that brings us to our third step, which is to write down our formula. So we're going to write down our formula now. So we'll say f prime x equals to the limit as h approaches 0 of f of x plus h minus f of x all over h equals to the limit as h approaches 0. F of x plus h is that whole part. So it's 2x squared plus 4x h plus 2h squared minus x minus h minus f of x. So we're subtracting our function, original function. Minus f of x will be minus 2x squared plus x. So once again, minus f of x minus f of x will equals to minus 2x squared plus x all over h now. So all over h, which is equal to the limit as h approaches 0. So let's simplify. 2x squared and minus 2x squared cancel off, and we're left with minus x and plus x. So now we just left to remove a common factor here. So let's take out h as our common factor because we want to cancel that bottom h. Okay, so what we left with 4x plus 2h minus 1. So let's see. So we took out h here. So we're going to be left with 4x. We took out h, we'll be left with 2h. We took out h, we're left with negative 1 over h. Right? So h and h now cancel. So now it's time for us to substitute h equals to 0. So when you substitute h equals 0, remember that this here plus 2h will become 0. So now we can conclude that therefore f prime x is going to equals to 4x minus 4x minus 1 is our solution. Final step would be to check your answer using the rule. If you use the rule, see, 2 times 2, so f prime x equals 2. So 2 times 2 is 4. Subtract 1 from there, so it will be 4x, and then the derivative of minus x is minus 1. F prime x is 4x minus 1. Remember, you can't use the rule if they say find the derivative from first principles. So you have to show all this working, okay? And that's your answer. So using the rule is just a check in this particular example. In this next example, we're going to be looking at the following. 7.2.1 says determine d subscript x. So the notations for finding the derivative using the rule will be d subscript x, dy dx, or f primed x. These are the notations for finding the derivative using the rule. Remember the rules now for finding the derivative, right? You can't have any brackets, so you have to open the brackets, because remember the rule for finding the derivative is as follows. If f of x equals to kx n, then f primed x is equals to k n x to the n minus 1. So every term has got to be in this form, kx to the n, before you can find the derivative. All right, so let's open out those brackets. 7.2.1. So for 7.2.1, we're going to open out those brackets. So we've got x plus 1 into 3x minus 7. We've got x plus 1 into 3x minus 7, which is going to equal to, let's open this bracket. So once again, x plus 1 into 3x minus 7. So we've got a binomial times a binomial. X times 3x is 3x squared. That'll be minus 7x plus 3x and negative 7. Let's simplify. 3x squared, that'll be minus 4x minus 7. Therefore, the derivative is now going to equals to 2 times 3 is 6x, 2 times 3 is 6, subtract 1 from there. The derivative of minus 4x will be minus 4, and the derivative of minus 7 is 0. So the derivative of a constant, remember that the derivative of a f prime x of a constant is equal to 0. Okay, so the derivative of a constant is equal to 0. Let's look at the next example. So here we got find dy dx if y equals to, here we got the square root of x cubed plus or minus 5 over x plus half pi. Okay, now firstly, right off the bat, half pi is a constant. So that's going to equal to 0, right? Let's take care of the square root of x cubed. Remember now, the next thing that we ought to know is that there must be no roots when you find the derivative using the rule. So 7.2.2. Let's have a look at that again. Okay, so y equals 2. So the square root of x cubed is going to equals 2. So y equals 2 the square root of x cubed minus 5 over x minus 5 over x plus half pi plus half pi. Now this is y, so let's now sort this out. So the square root of x cubed will be x to the 3 over 2, and here minus 5 over x is now going to equals to minus 5x to the minus 1, and here we're left with plus half pi. So now every term is in the form kx to the n, kx to the n, and this is just k. So dy dx, the derivative, is now going to equals to 3 over 2 times, right, the coefficient is 1 there, so it will be 3 over 2x, 3 over 2 minus 1. 3 over 2 minus 1 is going to equals to half. And here, 3 over 2 minus 1, you can always use your calculator to double check, right? 3 over over 3 over 2, 3 over 2 minus 1 equals to half. Okay, and here minus 1 times minus 5 is plus 5x, minus 1 is minus 2, and that should be our solution. So we'll leave it as that. Okay, so finding the derivative using the rule, make sure that in this example no brackets, no roots, and no x terms in the denominator. Okay, so remember here for 5 over x we use this particular rule, which is, remember, 1 over x is equals to x to the minus 1. For getting rid of the roots, remember that if you have the nth root of x to the m equal to x to the m divided by n. Okay guys, remember that this question was in the November 2017 examination paper. Alright, if you haven't subscribed already, don't forget to subscribe to my YouTube channel